Hi, this is Paul and Spencer, and we will be demonstrating area under a curve. So say, for example, you wanted to find the area under this curve x squared over 2 from 0 to 3. So that would be this area right here that we're coloring red. Oops. So to find that, you would take the integral from 0 to 3 of x squared over 2 dx. And when you do that integral, that comes out to be 9/2. So the area of this red section is 9/2.
Here is another example of how to find the area under a curve of sine of x. If you wanted to find the area from 0 to pi, this area in here, you would take the integral from 0 up to pi sine of x dx. And when you plug that in, it comes out to be 2. So the area under this curve right here is 2. Now, say you wanted to find the total area from 0 to 3 pi halves of sine of x, which would be this area and this area. So what you would do is take the integral from 0 to 3 pi halves sine of x dx, and that comes out to be 1. The reason that is 1 is because area above the x-axis is positive, while area below the x-axis is negative. And we found earlier that this was 2, and half of this region would be -1. So 2 minus 1 equals 1. So that would be the area. This is what is called finding the net area.
Okay, so now let's say we wanted to find the total area from 0 here to 5.28 here. We would take this blue section, so this blue section plus this yellow section. We would need two separate integrals, so one for the blue section, so we'd need the integral from 0 to 2.34, which is this point here, of our equation, f of x dx, and that comes out to be 4.78. And then we also need this yellow section, so that's the integral from 2.34 to 5.28, right here, of our equation dx. And that comes out to be -3.86. So now if we wanted just the net area of these two sections, we would, or from 0 to the 5.8, we would just add these and get 0.92. But since we want the total area, not the net area, we need to take the absolute value of these instead, because so that it makes both positive. So the total area, when you add those, comes out to be 8.64. So that's the total area of this whole green section right there. So as we've seen, if you wanted to find the area here from this section, you would take the integral from 0 to 2.34, is this point here, and that will give you a of our equation f of x dx, and that will give you a positive number. But say instead that we wanted to find the area of this blue section here. So the integral from 0 here at this point is negative 1.62. So from 0 to negative 1.62. So we're moving from right to left. Right to left here. So we're going in the opposite direction. That integral is going to come out to be negative because we're moving from right to left this way. So, and that number comes out to be negative 3.7. So, but then if we wanted to do, say, instead of from negative 1.62, we wanted to do the integral from from 0 to negative 2. So that would be right here, negative 2. So then we have this little slice of this part down here. So let's make that green. So the area of this little slice here is going to be positive because we're coming a negative, we'll have a negative going right to left, and then we're also down here below the x-axis, so that's a double negative. So the integral from negative 1.62 to negative 2 f of x dx will equal a positive, which that value is positive 0.36. So now if we want to find the net area of this whole section from the integral from 0 to negative 2, and so yeah, so this one up here equals the negative 1.62. So we want to find the net area of this whole red section. So 0 to negative 2 of f of x dx. That's going to be these two added together, which that comes out to be negative 3.33. So the net area of this whole section from 0 to negative 2 is negative 3.33.
And this has been a presentation on how to find the area under a curve by Spencer and Paul. I hope you enjoyed this video and learned lots. Goodbye.